Hello all and welcome to this video. In this project I'm going to show you how I built a RAG document intelligence application. It's not very huge and fancy RAG application, but it satisfies the need for stakeholders. Before do anything, let me show you the final result to see that application and see how it works. As you can see, this application is not very sophisticated in terms of the UI. We have very simple design. I'm going to ask some questions about the specific topic that this RAG application is built on top of that. I mean, the RAG application is not like the chat application. It is going to provide you with some specific questions which might not be findable in other companies or on the internet. Because this is a RAG application, and RAG is going to help the company, the people working in a group or in an enterprise to solve the questions about some documents which are exclusively related to that company, and they are not findable on the internet. This specific application is on top of some medical specific documents. And we will go through the project, we will go through all the steps, which kind of documents they are and everything. But before do anything, I would like to show you how this application works. For example, here, I'm going to ask a question. I'm going to say, can you tell me more about molecular profiling, NSC, LC, actionable alternation? As you can see, the topic is so specific. And it's very rare that somebody asks this question on the internet. And even if they do like the real GPTs or chat completion, they will have some general information. But here in this RAG application, we are specifically looking for the specific information stored in some specific files that they are exclusively for that company. So let's ask this question, and the RAG platform is just retrieving all the documents that this platform and application is built on top of that to reply the answer. As you can see, the RAG says, okay, this topic based on a provided the documentation, this is the table, this is the all information and everything. And also it is said the source is here. As I said, we are going to implement the RAG application. As you know, the RAG application is specifically used for some specific documents. It's not for the general document. For our project, we are going to work on clinical documents. As you know, the clinical documents based on the PII standards for personal identification information, they are super critical and secure. So it's just something that you can find this kind of information over the internet. So that makes sense for this kind of data. The companies are going to use the RAG platform or some kind of RAG application. Platform is a very huge wording. I'm not going to use the platform. It's just a simple application. So the process that we are going to do is that we have some PDF documents. We are going to make a RAG on top of those documents. And RAG means Retrieval Augmented Generation. It means whatever the users see in application, it's not all of them coming from the data or coming from the PDF. It is coming from PDF plus some information that LLM model can create for them to enrich, to augment that data for the user. So let's go and see those documents. However, those documents are very specific for medical industry, but let's take a look at the document to get familiar with the context of the document. As you can see, if I scroll down, we see very specific information. And to me, they are very hard because I don't have any clue about it because I'm not the medical expert. But if somebody who is working in a medical industry can use this RAG application if they need this kind of information. And It is for medical, but it makes sense if we have some documents about the insurance, if we have some documents about even the sports, anything, because every single company might have some exclusive documents that they are not on the internet. They would like to have some policies, they would like to have some internal documents, and they're going to have the application that the employees use that application and retrieve the data and get more and more information about those documents. This specific project is about the medical. This is just one PDF file. The rest, all of them are the same in terms of the structure, not for the data, definitely. And the structure of the file is PDF because before doing any RAG application, we should make sure about the structure of the file. It can be any unstructured format. It can be PDF, it can be Word, it can be even CSV, or even some data from SQL database. It can be anything, but we are going to use the LangChain, and LangChain library has different sub-libraries that can help us to extract and parse data based on the specific data structure. So let's go ahead and let's see what is the main object for this project. Now let's talk about the necessity of doing such a kind of project. As you can see, the manual document search is fundamentally insufficient. You cannot open the document one by one and scroll down to find your information. It's not sufficient and it takes too much time. Because instead of doing that, you need to focus on your expertise. You don't need to open one document after the other one. You should focus on what you're looking for, not just looking to find a document. RAG can help us. The other one is that in some kind of unstructured format, the critical data is trapped inside some complexity. I mean, some information, some specific and important information sometimes are just trapped in some sections of the file and we cannot find it. And time spending searching that I just talked about it is so important for medical. For example, as somebody who is going to work for the patient, instead of just looking for the file, just focus on, for example, the patient or the file or the job that you're going to work on that. So all these things, all those bottlenecks can convince the stakeholders, the managers, to build some kind of application. So we have the opportunity to improve the quality of extracting data from those kind of information and those kind of documents. So here there is a thing that RAG application can come to play. It can interact with many scattered data through natural language. You can just chat. You can just chat and ask on your own language even. And it is very helpful to have different kind of documents and just extract the data that we needed. And it can have some kind of synthesized answer or augmented answer. For example, if we have one word, one specific keyword on a document, okay, the RAG application can retrieve it. But after that, even with help of LLM, we can synthesize it, we can augment it and enrich more information about it, which is super helpful. And even later, we can enrich the initial document with RAG, not just only retrieve the data. We can use the help of LLMs to enrich those kind of documents. And all this process can be powered by LLMs, which are trained over billions of data and parameters that can help us for this specific project. Now it's time to work on the RAG blueprint. Blueprint means what we are going to do. What is the outcome that we expect? So let's see the process that we are going to do. First of all, we are going to ingest the data. Definitely, we are going to ingest the PDF file. We are going to parse the data based on a document structure, and then we are going to chunk data based on a different criteria. After that, we are going to go to vectors. It means the data is just a language, it's just text. And ML and AI doesn't understand the text. They only understand the number. So we are going to embed the data. And then we're going to store those embedded data in a specific database which stores the embedding, which is called vector database. Then we are going to go for retrieval section. Retrieval means, okay, we have some kind of vectors in our database. How we can retrieve those ones, how we can call them. This is what we're going to do in this step. And after that, in the final section, we're going to generate or augment those vectors, those informations with help of LLM to answer the user questions. This is all the steps that we are going to do. However, we have so many steps within each of them that I'm going to show you one by one how I did all these steps. Alright, now before going to the code section and what we did for every single item, I should talk about the parameters. Before I start any project, specifically some kind of AI or ML project, I will create a file which is called parameters. And these parameters is just handling all kind of parameters that in every single section of the project that we might need it. For example, based on for every single section here, for step number 1, it is for RAG phase ingestion. What kind of parameters do we need? We need PDF directory, where the data is stored. For section number 2, what kind of parameter that we have? We have some kind of chunk size or chunk overlap. These are the parameters that we might need to change it. Or for example, for next phase, we are going to talk about the embedding, which kind of model that we are going to use. Or in the next step, we are going to store the data, where we are going to store it. It can be even one parameter. In number 5, we don't have any parameters, so I just left it as empty. In number 6 phase, it's just for retrieving data. Okay, what is the top K? What is the score threshold? I will talk about all of these things when we reach to the code section. Number 7 is just to augment the prompt system. We don't have any parameters. And the last step is just for augmentation process, the answering, which kind of model that we are going to use, and what is the max token for that model. This is all kind of parameters that we have. And all of them, as you can see, are changeable, but we will see how I just found these ones as the best parameters for my project. Okay, now it's time to start the phase 1, ingestion and vectorization. We are going to just read those PDF documents, chunk them based on some parameters that we just saw, embed them or just change them to the number, embed them, just change to the vector, and then store them in a ChromaDB vector database. For embedding class and for ChromaDB, I have 2 different classes, and then when I have the classes, both of them, then we can do the embedding process. Now let's start this phase in VS Code. Okay, now let's start the ingestion phase. Here we are going to work on ingestion document. It's a script and we are going to start. First of all, which kind of parameter that we are going to read? I'm going to read the PDF directory. It is the place that the file is stored and it's coming from the parameters, the document that we just saw. Then I'm going to use the LangChain library, and specifically I'm going to bring the PyPDF loader. And then I import the pathly because I'm going to just type with the different directories or different folders in my project. Then in step number 1, which is for data ingestion, I just create a function ingest PDF document, and it gives the PDF directory as an input argument. Then I create just the empty list and I put all the documents inside it, but this is the empty list. Then I read all the documents that they ended with PDF, regardless how many do I have. Whatever it is, just the PDF, this function is going to read it. And after that, for every single of them, I'm going to load them based on a PDF loader, and then I'm going to store all of them in the list. What I'm going to store? I'm going to store the two metadata, the source file and the file type. Because source file, I'm going to have the source of the file where this data is coming from, and file type, I'm going to have the PDF file. And then when everything is ready, I just say, okay, the total number of the document is loaded, how many, and that's it. And just because we are going to work at a modular format, I should have the main constructor to then have a pipeline as a complete and automated process. This is just the ingestion section. After this step, we can go for a splitting section. Again, in a splitting from the parameters document, I'm going to read two parameters, chunk size and chunk overlap, those two parameters that we just set it. Then from the lang chain, I'm going to import the recursive character text splitter. These text splitter, based on a chunk size and based on a chunk overlap, they are going to chunk all my documents. For example, if we have one page of the PDF, after chunking based on the chunk size or the window and how many each chunk can have overlap with each other, one page of the document can be split to 2, 3, 4, or even 5 chunks. These are the parameters, chunk size and chunk overlap, that we can set it. Because RAG application, for reading the data, it can't read the whole document. It can't read even one page of the document. It reads the chunks, and every single chunk is just the context. For example, Apple is a company and Apple is a fruit. If you have one chunk for Apple, which is talking about the Apple company, and the other chunk is about the Apple fruit, we have very good chunking, because one chunk is totally about the fruit, one chunk is totally about the company. Later, if you're talking about the Apple company, then the vector database can embed these two chunks together, because this Apple, which is about the company, which is talking about the technology, has nothing to do with the fruit context or the fruit chunk. These two are cosine similarity, and this is the best way for chunking and just embedding the data. Okay, let's go for splitting the document. After just define the text splitter, then we can apply those text splitter to chunk all the data, and then just print the result for us. And again, just because we are going to have the full pipeline, we have the constructor as the main constructor. We have two things, the PDF document, because we are reading it, and also the chunk parameters like chunk size and chunk overlap. This is the splitting section. All right, now we can go for the next file, which is for embedding class. Here we don't have any output, we just make a class. This class again reads something from the parameters file. This is vectorizer model name. We are going to use one open source vectorizer or embedder model. And this is what we set for parameters, which is mini LM model. Then from the sentence transformer from PyTorch, we just import the center transformer. This is very, very heavy library. Then we import NumPy and just typing for making the list and dictionary. Then I create the embedding manager as a class. This embedding manager has two functions. It has data load or the load model, and it has the generate embedding. First of all, we should have the load model. First of all, we are going to load the embedding models. Whatever the model that we have, this is stored on the internet. This is open source. We are going to read it. Based on a sentence transformer, we are going to read and get those embedding model. When the model is ready, we are going to go for generating the embedding. And in this step, we are going to just get those data that we have and then push those every single chunk inside the generating model. Again, just because we are going to make a class here, we are not gonna input anything or make an output or having any constructor. We just save all this process as an embedder. From now on, when I call embedder, then call this function, or embedder call this function, means I have two functions. Whenever during the project I need these two functions, I just need to call the embedder class. Now we can have another class for vector store class. What does this class do? This class is going to store the data in our vector database. Again, we need to have something to import from the parameters. This is vector store directory, where we are going to have those vectors stored. I'm going to just set next to my data. Then I'm going to import some libraries, and the most important library is ChromaDB. ChromaDB, one of those vector databases that I'm going to use it. You can use Face or even Quadrant or any other vector database. Again, this class has two functions, or even three functions. Yeah, three functions. One function is initialize the stores. It means before do anything, we should make sure the ChromaDB is up. The ChromaDB is ready to read our all information. So this is the initialize store. After the initialization, we can now clear the collection. Why this process is important? Let's say you embed your data, you have some vectors on your data store, and then you go ahead and launch the project. After a while, you notice, oh, one document is left, so I need to vector it. If you don't clear the collection and you have to do all the vectoring process again, you will have duplicate for those vectors that you have already done. So whenever you call this class, first of all, it clears whatever it has in a vector store and again do the process. This is very, very important, because if you don't have this function, whenever you run the vector stores, you are just having duplicate, and it will cause a very, very big data store. After this function, we can go for adding the document. This is the process that we can just store all the vectors inside our vector stores. Again, the input for vector store is coming from the embedding. First, we need to embed and by embedder class, and after that pass it to the vector store class. And vector store is just store the data and it doesn't change anything. Then at the final step, I just have the vector store class, and it is nothing but a vector store class. And the final step is that, okay, now I have two classes, one class for embedding, one class for vector store, and I have also different chunks that I have from the retrieval splitting phases. It means we have chunk here, we have two classes. Okay, now for every single chunk, first embed based on embedder, which is coming from embedding class, then a store, each of them in vector store, which is coming from the store class. Now we just convert all the PDF documents to vectors, and all those vectors now are stored in our vector database. This is just phase 1 of the project. Alright, now it's time to go for phase 2. This is a retrieval and LLM generation or augmentation phase. Now we have our data in ChromaDB as a vector data store. Now it's time to select the top K, then have the prompt structure, and then go for Anthropic Claude up to 4.5 model, LLM model, to extract and augment the data. Let me talk about the top K. What does top K means here? Whenever we have a query from the user, that query goes to the vector store, which is the ChromaDB. The ChromaDB doesn't see all the vectors. It only sees, based on K nearest neighbors, it only sees the nearest vectors based on that embedded query. And then based on those ones, let's say the ChromaDB based on K and N says, okay, this query can match to these 15 chunks or 15 vectors. It ranked all those vectors based on the similarity, based on cosine similarity or the distance. Whenever the cosine similarity is high or the distance is down, it means these two chunks are totally close to each other. Just remember that apple that I just explained. And then it just brings back the top K, how many of those 15 we would like to make a full context and pass it to LLM. For example, top K is a top 3, for example. Just 3 of them can combine together as a context, then we can pass this single context to the LLM. Or we can have top 5. 5 of them can combine as a unified context, and then we pass those unified contexts to the LLM with the prompt to generate the data. K is very important here as our parameters. Now let me go to the code and explain all these steps. Okay, let's start with the parameters. As I said, the retrieving file is going to have 2 parameters, scores threshold and top K. Threshold means how much they can be similar to each other. Then we need 2 scripts. We need vector store class and embedder class, and just typing as the library that we need. Then we create a new class which is a RAG retrieval, and it has some function. The first function is retrieve. It means every single query is going to first embed based on an embedder, and then go from the DB, ChromaDB data store, just retrieve those data. And for every single chunk that this function is going to bring, some information is very important. First of all, the similarity score. If the similarity scores that the model is just retrieved is less than the similarity scores we set for our project, just leave it. We don't need it because the score is lower than our expectations. And then if this is ready, if the chunk is matched to what we want, just store some information, the ID of the chunk, the content, what that chunk is talking about, the metadata, what is the similarity score, what is the distance, and what is the rank. After that, they can pass and create the context. For example, let's say here, after this function, we have 5 documents. This function is going to make the context based on those 5 documents, and then it passes at the context part as a final result for our retrieval section. And this is just a class, we pass it, it needs 2 things. RAG retriever has 2 arguments. One of them is vector store, which is going to read the vector, and embedder, which is going to write the vector. And then, just because this is the full pipeline, it's going to be as a main constructor. And it is just a test that I just pass it, however, it's not relevant for this project. You can have a test text, whatever you want, and then you can just retrieve the information that you want. It means after this project, we can talk with our database. We can talk with our data, but it is not augmented because we have not passed this context to the LLM. It is just showing whatever it is in a PDF file. No more information, no more context, nothing. It is very, very pure and rigid. It's not very user-friendly because it is just some text or just some sentences. We need to pass this context to the LLM to make it more readable for the users. But before pass, we need to have some kind of prompt. Because all LLMs needs to prompt, and this is the place that we did some prompt engineering. We said, okay, this is the system prompt. It's not the user prompt. Definitely, we are going to pass it to the system. We said you are a helpful assistant for some medical questions. You need to have all these rules. Then you're going to provide the information for the user. After that, this is the final step. We have everything. Then from the Anthropic, I'm going to use the LLM Anthropic. You can use the OpenAI or the Grook, any LLM that you are going to get the API. Then I'm going to load one important library. This is load.env. Why? Because I'm going to store my API key in a safe place, not inside my code or my project. Then I load my API and just pass 2 things from the parameters. One is LLM model, one is the max token, how many tokens that LLM needs it. Then I'm going to just read 2 things. RAG retriever, which is the encapsulated version for the embedder and vector database, and we have system prompt here. Then we have just one function, ask with context. It means here we pass that context to the LLM, and in the next step, LLM is going to make the response for us based on the model we set, based on a token, based on a prompt and based on every single conversation history that we are going to have, because history is very important during the chat, and we are going to append all the histories, and the role is for the user. Also, we are going to append the conversation history from the role of the assistant. All those conversations should be appended because we need some kind of history when we are going to chat with the application. And after that, the final function is just run rag chat. It is just running the chat and run all the process, which is going to read from the Anthropic API key, and this is just the final constructor. This is the whole for phase number 2, which is for augmented and retrieving the data. Why those parameters? Why those chunk size? Why that chunk overlap? Why that embedded model and why that LLM model? All of them are coming from the experiments. All of them are coming from hyperparameter tuning and LLM tuning. This is the process that I'm going to do. Those parameters that we set in an initial step of the project and we create that pipeline based on that, it is just the initial step. But we don't know this is the best parameters or not, as long as we run all the experiments based on the different combinations. Because medical data needs the zero hallucination accuracy. Medical, based on the context, is very important. If we have hallucination, if we have some extra bad information from the chat, it might give the bad results to the users. So default setting is very critical in this stage. So I'm going to optimize some parameters. I'm going to optimize the chunk size, the chunk overlap, the top K, the retrieval model, the score threshold, the embedded model, all of them. I'm going to just do all the hyperparameters tuning to make sure each of them gives me the best one. I had 256 unique parameters combination to just tune our model, and all of them, how I did, definitely not manually, with help of MLflow. MLflow is one of the best tools for model registry and experiment tracking. I use it for experimentation tracking because it is very good interface for comparing the different outputs. And for this specific project, the precision and then recall is important for me. Why precision is first? Because first of all, I'm going to make sure how much the model's result has hallucination. If the precision is so high, it means whatever model tells me, this is exactly correct and I have it. And after that, I go for recall to make sure all the data that I have, the model is consistent. So the first step is that the result of the model should, all of them are findable in our documents. Now let me show you all this process in the VS Code. Before doing evaluation, we should have evaluation datasets. Evaluation dataset, it means we just created some data sets and we just captured from the data. For example, I open every single document and I find one question and expected keyword and answer, and I said where this data is coming from. For example, for ID number 1, the question number 1, this is a question that I made, and based on a keyword that they are definitely for this question, and I say from this document, or again from the second document. And all these documents I just created for all of them. As you can see, I just created every single document. I made some questions. These are our evaluation set, and the result of the model is going to compare with these documents. Then it's time to go for the metric. Okay, I'm going to optimize my model, but based on which metric? Here's the thing, I'm going to have hit rate. Hit rate means at least the LLM should have one result which is findable from my document. If hit rate is 0, means that performance is not good. Then is about the precision. Precision means what out of the vectors, out of the chunk that the LLM model suggests me, how many of them are correct. So this is very important for my case. But recall means out of, for example, 10 chunks that they are related to these specific queries, how many of them LLM just captured. This is just the other way around for talking about the evaluation. Evaluation query is just for encapsulate those queries, all the metrics that we have, all of them are encapsulated as one function, and then I just aggregate it because it is only for one query. If you have 10 query, 12 query, how many the model is going to do during the evaluation, we should have aggregation. For example, for hit rate, I said mean, precision mean, recall mean, total hit, this is just the sum, and how many number of the questions that we ask. The questions is here. We have 20 questions, if I'm not mistaken. We have 20 questions. So this metric is going to base on an aggregation of the 20 questions. And then in the final steps, I'm going to use the MLflow for doing all the steps. And I have to import some classes, everything, all those pipelines are going to have here. Because for every single experiment during the MLflow tracking, all of them should run the pipeline from the scratch for number 1, number 2, number 3, all of them for 256 combinations we have based on the parameters that we have. And this is the parameter grid. For chunk size, I said out of these discrete values, they are a choice. So the grid is going to work. If it was the continuous, we should go with the random or Bayesian, but this is the parameter for discrete we can do. For embedding model, I just selected 2 models out of this model. I'm going to choose 1 chunk overlap, top, K, and score threshold. After that, I'm going to build the index because from the start, as I said, now we have something in our vector stores. We are going to just remove whatever we have, build all these indexes based on ingest data, embedding, and just store in a database. All of them are going to do run over and over again. And finally, just run the evaluation that we just created here. And it is going to come from the evaluation dataset. And finally, just return our data. And this is just for tracking in MLflow. How this run is going to be done in MLflow. With MLflow tracking, I call the experiment as a RAG hyperparameter search and just set some parameters. These are the embedding model is coming from this section, size, overlap, K, threshold. All of them are here. Model size, overlap, K, and threshold. And then based on embedding, I'm going to log parameters. Which parameters? All those parameters. And also we have some metrics. These metrics are just aggregation that we have. So we need to store 2 things, parameters and metric. And finally, when everything is run, the MLflow is going to just show me the final result. And also this is some kind of construct. Now, these parameters that I just showed you in the initial of the project, all of them are coming from what MLflow told me after evaluation. It means right now they are the best combination based on all these choices that we have here. But initial of the project, when I wanted to start this project, they were different. I remember it was 600, but after the evaluation, I noticed 1000 is good. Why? Because based on a different combinations, MLflow suggested if you go with 1000, the chunk overlap is 100. You use the vector model as this model, and threshold is this number. And if you go with top K, you will have the best result. That's why I set these things for my parameter. Okay, here we just saw how we can change the baseline model and parameters to the optimized pipeline. So from functional baseline, we just reach the final optimized system. From the default parameters, we have the data backend chunking and overlapping. So we have all these things, and now we have very, very good model based on our information. However, we have just 15 documents. In a real world scenario, we might have many, many documents, but this is not a real project. So this is the evaluation metrics. Now we can go for the next step. Whatever we need, it is just a code. If we want to run the application, we just open the terminal and ask it, but it's not something that user wants. User needs the UI. User needs the application. So here, there is a thing. We have the user interface here. We have the Streamlit applications that we created. This application is on top of the Docker image. We are going to containerize all the informations, all the projects as a package, as a Docker image. And after that, whenever we have this Docker image, we can deploy it. I prefer to deploy this Docker image on Hugging Face. You can deploy on AWS. Somebody else is going to deploy on Amazon, Azure, or Google, or even third parties. I prefer to go with Hugging Face with deploying LLM models and ML models in Hugging Face is super easy. So the process is that we are going to create the application. Then I'm going to containerize all the projects that I have. And then the image is ready. I'm going to set this image to Docker Hub. And after that, from Docker Hub, I'm going to read my application. Okay, this is the application that I created. As I said, it's not a very sophisticated application. It is just a very simple application to talk with models in a better way, in a better UI. We have some page config. As I said, I'm going to use the Streamlit and I'm going to import the pipeline. The pipeline, all the pipeline is going to come to all these steps. Then I'm going to just pass this config. And then I'm going to have some markdown or, okay, what is some kind of a style or the design for my project. Then I'm going to have the sidebar. For sidebar, I'm going to have just a header. Then I'm going to say how many documents I chunked. And then I'm going to have one button for clear the conversation. It is just the reset the session and reset the conversation. And finally, I just sign the application with my name. Then this is the chat area. This is the right side of the application. We are going to have just the state of the session. This is the chat section. And then the pipeline query is going to go all the way from the retrieving data to make a context, select the top K, make a context, give it to LLM and augment the data. This is just the application. Now it's time to go and Dockerize all the projects and all the files that I need. Definitely, for example, the API key is not going to be in a Docker file, or some documents that we are just saved for the project. They are not go with the Docker file. All the important documents I'm going to put on a Docker file. After that, based on a Docker file, I Dockerized all the projects. It means whenever I want, I can use that Docker file. Let me show you how I store in Docker Hub. As you can see, this is my Docker Hub, and I stored all the images as a Mehrdad 66 rag-app. This is my project, and as you can see, the size is almost 3.5 gigabytes. So this is very huge. I said the file is not very huge because of that sentence structure. It is coming from the PyTorch, and PyTorch is very heavy library. And as you can see, it is stored in Hub. It means in Docker Hub, I have something, and whenever I want, I can just call my Docker Hub, and I don't need to store my project inside my system because I have the image in the Docker Hub. And even if I don't have the Docker desktop, I have it because it is some kind of cloud for Docker. But it's not runnable in the Docker Hub. It is just the image. I should deploy this image somewhere and just run the application. That's why I use the Hugging Face. Now let me go to the Hugging Face and show the deployed project. Now I'm in the Hugging Face, and this is my profile. It's not very sophisticated. I'm going to make it a little bit better. As you can see, 20 hours ago, I just deployed this RAG model. And when I create, and this is the RAG model, and this is our all information. And as you can see, this is the running. Now let's give it a try for this project. For example, I open one document which is for cancer. I just select this section and just copy, and then go back to the RAG model and ask the question about this topic. Okay, here now I'm going to ask it, do you know what is it this one? And the RAG is thinking, so what is this specific topic that I just asked? And it's going to retrieve all the database and bring it back for me. It said based on just the information that you said, it is coming from the breast cancer diagnosis treatment PDF. And this is all information. It's talking about HR plus, HR2 minus, hormones, receptor positive, HR2 plus, blah, 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 all this information. And these are the general principles. It means the general principles, it's not mentioned in the document. This is what kind of the context plus with the prompt pass to the LLM, and LLM generate and augmented the information for us. You see, this is more user-friendly to read it instead of just read the document. But let's come back to the PDF to see, do we have this kind of information or not? All right, you see here, yes, exactly, we have HR plus, HR minus 2, and all those information that just RAG told us. And as I said, this is just 3 bullets, but RAG told me more and more. Why? Because this information is just augmented based on that LLM model. Why? Because based on this context, along with that prompt, we pass it to LLM, some kind of the chat. We copy this section, chat with LLM, just paste that prompt in the chat application. Instead of that, we just did all the process with RAG application. Yeah, this is very good. And now we can, whatever we want, we can just ask from that application. All right, I just showed you in this project how we can go from raw data, from some specific documents that nobody has it, from some kind of chat with the LLMs based on our data, augment it and make it more sophisticated for users to just, with blink an eye, to grab the data that they need. RAG applications and RAG document intelligence is very, very critical for nowadays companies, because there are a bunch of data in every single company that you cannot find on the internet, but they are useful. And with RAG application, you can just set these kind of applications and just make the use of the era of the AI and ML. I hope you enjoyed this video, and if you want to download the materials, the codes, and even the PDF documents to talk with this LLM, just go ahead. In the description there is a link for the GitHub, also the link for the live applications. You can open the applications, you can chat with these applications. However, this is the RAG. You should ask the data which is coming from the PDF files. Also, those PDF files are stored in my GitHub. Again, I hope you enjoyed this video, and thanks for watching.